Welcome to the Exam Room Podcast, brought to you by the Physicians Committee. Hi, I'm the weight loss champion, Chuck Carroll. Thank you so very much for watching and downloading in more than 150 countries around the world and making this one of the healthiest podcasts anywhere on the planet today. Today, we're going to be talking about physical activity as we get older. And you may think moving your feet has nothing to do with what's happening upstairs in the brain, but my guest today says that assumption would be absolutely incorrect. With that, we welcome the Director of Translational Neuroscience at Advent Health Research Institute in beautiful Orlando, Florida, the one, the only Dr. Kirk Erickson. Thanks for being here, my friend.
Great. Thank you so much.
What exactly does the Director of Translational Neuroscience do? That is an interesting title.
It is. Yeah, so I'm charged with trying to build a research program at the Advent Health Research Institute located in Orlando. So it's all about how can we take our science from the lab, the bench, to the bedside? How can we apply it? How can we learn from it? And back again, how can we learn from what's happening at the bedside and do science at the bench? And so this is really what we're framing and thinking of as translational neuroscience.
Alzheimer's rates right now are increasing, aren't they?
Yes.
Okay.
Yes. Yeah, the prevalence, unfortunately, as the population grows and gets older and older, we're seeing increased rates of Alzheimer's disease.
So how does exercise translate into a lower risk of cognitive impairment as we get older?
So one of the things that we've learned is that physical inactivity is a risk factor for Alzheimer's disease and dementia more broadly. So it's considered to be one of the modifiable risk factors because we can actually modify our level of physical inactivity. So we've learned that people who engage in physical activity have a reduced risk by about 50% reduced risk of developing Alzheimer's disease. And we still don't understand exactly how this works, why this works, but we do understand more and more that what's good for your heart seems to be good for your brain.
It's interesting we don't know how. I mean, like I'm sitting here just from, again, lay perspective. I have no credentials, no letters behind my name whatsoever. But, you know, I'm just thinking like, is it because the brain gets stimulated somehow when we exercise? Is it increased blood flow, better oxidation, all those kinds of things? I mean, I'm sure that you have gone over a million hypotheses out there. What are some of the more, I guess, prevalent hypotheses as to why this could be?
Yeah, absolutely. There's a lot of ideas and there's actually a good amount of evidence for a lot of them. But one of the things the way that I think about physical activity and exercise specifically is that it's a little bit like a sledgehammer in that it's a blunt force kind of tool to change your entire body. What that means is that when you exercise, when you engage in physical activity, you're not just changing one molecular or cellular pathway or just changing one tissue or organ system. You're changing everything. You're affecting everything. So there's everything from glucose and insulin pathways are affected. Inflammatory pathways are affected. We know that as you exercise, your brain secretes chemicals, neurotransmitters that positively influence learning and memory and mood and other outcomes. We know that the muscles, when you move the muscles secrete certain chemicals, and these chemicals in turn influence the brain. We know that when you exercise, you change your blood pressure. And blood pressure seems to affect the brain in a negative way, high blood pressure. So all of these things kind of combined are ways in which we think exercise is influencing risk for Alzheimer's disease. But we can't point to just one thing and say, this is how this is working.
Right.
But that might be actually why it works so well and so consistently across so many populations.
Because it is more than one thing.
It's more than one
all
pathway.
Working together.
Exactly.
That is really interesting to me. And how much exercise are we talking about? Does this mean that if you are, 75, you need to, maybe use that AARP card and get a gym membership discount?
This is a really important question because in order for us to be able to prescribe exercise as medicine for the prevention of Alzheimer's disease or as a treatment if you're experiencing some memory losses, we need to know what to prescribe. how much, how frequently, what's the intensity, what type of exercise is best. And unfortunately, we still have a very poor understanding of this. We think that it has less to do with the mode of activity and more to do with the intensity at which you're active. So whether you want to jump in a pool or whether you go for a brisk walk, that might not matter as long as you're doing that activity at the intensity level that really drives the heart and gets the heart pumping. So with that in mind, we do think that the effects are bigger and stronger when you're achieving at least a moderate intensity level of exercise. Now, there's still a lot left to learn around this. We still have a very poor understanding of how much is really needed. And there's a lot of questions that could be asked around this, right? So if I work during the week, I don't have much time, but I spend a lot of time exercising on the weekends, and I'm the weekend warrior.
Right.
Is that going to be sufficient, or do I need to have some regular, frequent activity throughout the week on a regular basis for it to really be driving that effect? We don't really know. Unfortunately, we don't have a good answer for some of these questions.
Where does that limitation come in? Is it because we aren't particularly studying that, or there are long-term studies that are underway that we just haven't finished getting the data for it, or
kind of a combination of both, to be honest? So
Okay.
we're waiting for a number of studies to finish and be released and published. So that's certainly one issue. But then second of all, we need more research in this area. There's so many questions. There's so many people that are asking these questions and wanting to know answers and looking for answers that aren't necessarily just pop a pill, I want a pharmaceutical. They're looking for, what can I do in my daily life that doesn't require me to go out and get a medication? What can I do? And we know physical activity is good. I can recommend physical activity, and I can tell you physical activity is good. But all of these questions around how much do I need to get, unfortunately, we do a bit of hand waving. We do have public health recommendations. Public health recommendations are a minimum of 150 minutes per week of moderate to vigorous intensity activity. And so that's really generally what we are recommending. But those public health recommendations, we don't know if they are applicable to brain outcomes, especially risk for Alzheimer's disease. So it might be that you could get less activity than 150 minutes and still reduce risk. Or it might be that you need to achieve more than 150 minutes. So this is really where we're still struggling. We still don't know exactly the answers to some of these questions.
Let me ask you this. A lot of, I guess, what frustrates people as they get older and they start to experience whatever the health ailment is, you know, they always say, well, I wish I would have done things differently when I was younger. You know, do people who are up there in their years still see benefits when they begin to exercise? Or is there a point where, well, I'm 75 and it's too late for me. I'm too far gone.
Yeah, it's a very good question. And I have people that ask me this as well when they join our studies. And one of the things that they do, they sometimes tell me is that they say, Dr. Erickson, I have never exercised a day in my life. I think that it's too late for me. And the answer is it's never too late. Actually, we bring in people, we get them active, we get them enjoying the activities that they do. And we see tremendous benefits when they start exercising. So even if you've been sedentary, even if you've been inactive, even if you've really never exercised or barely exercised a day in your life, you can still benefit even at a late life. Now, that being said, are the effects bigger and better the earlier you start? Yes, that seems to be the case. But even there, we're relying then on these retrospective reports or longitudinal observational studies that really are very difficult to do and are fairly rare.
Right.
So we do know that it does seem that starting earlier in life is better, but it's never too late to start.
Right. So maybe if you get 80% as effective as somebody who was going in their 20s and 30s, That 80% is still pretty darn
It's
good.
still pretty darn good. Exactly.
Yeah,
Yeah.
man, I like that a lot. What about strength training? It seems like we're talking a lot about cardiovascular type of exercising
Mhm.
here, making sure that
Mhm.
you get out of breath a little bit, or as my friend Dr. Gemma Newman would say, out of puff.
Yeah.
Um, Strength training, a lot of people wouldn't associate, pumping iron with having a clear mind, but I believe research is coming out now that's showing that, yeah, muscles actually make a big difference when it comes to memory.
Absolutely. Absolutely. Yeah. There's some really compelling evidence coming out that that strength training, resistance training really has a powerful effect on the brain and cognition and memory function. We started out this field, a lot of us started out this field primarily focusing on aerobic activity, brisk walking primarily. And there were several reasons for that. One is that it's the most common form of activity. So
Mm.
we were trying to target something that wasn't just going to be only a small group of people we're going to be able to engage in. We wanted to try to engage aerobic activity because that's really what a lot of people target. And at the same time, we were also concerned about methodologies around safety for strength training and resistance
Mhm.
training in that age group. So we want to make sure that I think we intentionally moved a bit slower in the resistance and training space compared to aerobic. So aerobic, I think the evidence and the data is really much more well-founded at this point for its benefits. Resistance training is coming out, and it's almost there with being much more demonstratably beneficial to brain and cognition.
Would that fall into that at this point, window of, well, you should do it X number of days? And I know because we don't have the hard data, but would you recommend
Yeah.
maybe just generally speaking 2 to 3 times a week, busting out the resistance bands, trying to build something up
Yes.
like that?
Generally around 2 days a week. Generally around 2 days a week. Yep.
Okay.
And doing that resistance training, getting some of that strength training in, is going to be very beneficial.
All right. And I think it's important to note that a lot of these exercises that involve not cardio, but again, resistance training, these are things that you can do at your house.
Right.
Push ups against the wall, use a chair, if you really
Exactly.
haven't done anything in forever. When you're doing the
Mhm.
studies, I mean, you just mentioned the patient who had never exercised a day in their life, but
Yeah.
are you working with some patients who really are starting from scratch and maybe are in pretty rough shape sometimes?
Sometimes they are, yeah. In fact, we have a lot of people that have, sometimes we use treadmills. There's a lot of people who have never used a treadmill before, and so it's a little bit awkward when you first start,
Mhm.
and you're not familiar with that pace, that regular pace, and where to put your arms and your hands, and how to walk in that way, especially at a brisk pace. So yeah, I think there's some education that goes along with learning what exercise to do and what experiences that you should be expecting. Some people we have to educate around what is a good type of pain to have,
Mhm.
level of soreness versus a bad type of pain,
Right.
and so it's these things that we often spend quite a bit of time focusing on, especially as people first come in.
How does the benefit gained from physical activity compare to some of the medications that are on market? I know that
Yeah.
those types of pharmaceutical therapeutics are very limited. We see more and more coming out, but I'm just curious if we're able to compare the benefits here.
It's a very good question, and we're hoping to do that with some of the new research that will be coming out, both in terms of in the pharmaceutical space as well as the non-pharmaceutical space. And I don't like. I think we need to be careful putting them head to head because
Mm.
they're very different types of interventions with different eligibility criteria for participation. And right, so for an example, we make sure we're bringing in people who aren't already running 5 miles a day, for an example, right?
Right.
That elite older adult athlete, right? But pharmaceutical trials, they can bring in any of those or all of those people. So a lot of times the eligibility criteria, the inclusion and exclusion criteria differ. So it's sometimes difficult to make head-to-head comparisons. But I do think that it's important to examine some effect sizes. So when some of the studies that are currently ongoing come out, we'll be able to see what's the effect size of an exercise intervention, like what we're doing, and how does that affect size compared generally to some of the pharmaceuticals that are out there. So we're getting closer to that. I would probably say that it's very likely that some combination might produce even bigger effects.
Do you, with your study participants, talk about nutritional interventions at all? Does that go into the exercise component?
It does often, yeah, and it depends on the type of intervention we're conducting, right? So if it's a kind of a multimodal exercise plus weight loss, or exercise plus some sort of dietary supplementation or dietary intervention, then obviously that becomes a major part of the conversation and topic. Part of the way that we think that we've speculated that exercise might work actually by influencing how it influences the brain and cognition is because of changes in body composition actually. So those things might be potential pathways by which exercise affects the brain. We've also speculated that maybe some people, when they start exercising, they start eating differently.
Right.
And so maybe some of those changes might either be confounding or enhancing some of the patterns that we see. So there's a lot of discussion about this, a lot of excitement on this to try to find out what the answers are.
It is pretty interesting. It's like you start to exercise and you just naturally gravitate toward what would be considered healthier foods, right? You just want to do the best for your body at that point.
But some people also, as you expend more calories, some people compensate by eating more calories as well. So if the driver of some of the benefits of exercise are energy expenditure, then maybe you aren't getting the benefits that you think that you should if you are just eating a lot more calories and kind of washing out all of the benefits of exercise. So this is where we're at. We're still trying to figure out some of these.
It is kind of a guessing game. I feel like every once in a while you get a piece of the puzzle that you can put down and affirm, but you don't quite know what the puzzle's going to be yet.
And I wish we could move faster in some of these areas to get answers, but it takes time, you know.
I mean, this is a pretty complicated puzzle, to use that analogy. This is not one of those 16-piece jumbo puzzles. This is like one of those like 800-piece puzzles that one by one the pieces are going there. How many pieces do you think we have in place at this point? 200? Maybe we're a quarter of the way there?
I think so. I think that's probably a good estimate. And I really think that what we know about the brain and exercise, I think we can be quite confident about. The brain is affected by exercise just like every other organ in the body. It's not special in this way. It's not immune to the benefits of exercise. So I think we can be very confident about that. All of these questions about the different parameters of exercise that are needed to optimize and enhance, maximize brain health, I think we still have a long ways to go there. How should these things be combined? As you mentioned, dietary factors, intellectual stimulation, other things that we're doing, our sleep behaviors, all of these things are contributing to our brain health outcomes, our brain health in late adulthood. And so how all of these things come together, like you said, into the single puzzle that we're trying to put together, that's remains the challenge.
Yeah, but you seem like it's a challenge you're up for. Like you get excited by trying to put this puzzle together, don't you?
I get very excited about this. Yeah. I love the science. I think it's really great to, with every question that we answer, there's another 6 questions at least that come out of that answer. And it's pointing us in a direction, right? We need to follow nature's lead a bit here and figure out what it's trying to tell us. What works, what doesn't work. And sometimes when we learn what doesn't work, that's almost more important than learning what does work.
Yeah. Well, before I let you go, a couple quick things I want to ask you about. Number one, blood tests seem now to be coming online where they can predict Alzheimer's with, I believe, 90% accuracy.
There's a lot of really excellent work being done with blood-based biomarkers for Alzheimer's disease. And we are definitely in that space as well. So we've been conducting our exercise interventions and trials to better understand whether exercise or how exercise influences Alzheimer's disease pathology and some of those pathways. And so I know, I'm very confident that in the next few years, there's going to be quite a bit of work coming out in that area.
I'm just curious, last question, to get your take on what we saw recently with Dr. Dean Ornish and his research that
Yeah.
came out. I mean, really focusing on lifestyle holistic type changes, primarily dietarily driven. Really promising results there.
Very promising, and he's not alone in that space. There's a lot of interesting work going on, especially with multimodal types of interventions where you're combining dietary, physical activity. There's a lot of work and a lot of excitement, and I really want to emphasize a lot of potential.
Yeah.
We know that there's modifiable risk factors, as we talked right at the beginning, modifiable risk factors for Alzheimer's disease and dementia. And by modifying those, we can alter our risk. And so this is the work that he's doing. He's been able to demonstrate that by modifying these risk factors, you can alter the not only the risk for dementia, but also as a form of potential treatment if somebody's already experiencing some decline. And I just think that there's so much excitement in these areas right now because people are not just looking at pharmaceuticals. You can't. I think if you're only looking at pharmaceuticals, you're missing a major piece of the puzzle.
Yeah. Yeah. All right. So 20 years from now, if we're having this conversation, how many more pieces are filled in that puzzle?
I hope almost all of it.
All right, Doc. Thank you so much for your time. This has been great.
Great. Thank you so much.